In this video, we are going to discuss maximum contiguous subarray sum problem. And the optimal solution of this problem is given by Kadane's algorithm. So this video is about how to solve maximum sum subarray problem using Kadane's algorithm. So let's go ahead and understand what this problem is. So we will be given an array having negative and positive integers, and we need to find the subarray in this array having maximum sum. So if this is the array, then in this array, the subarray having max sum is the one with elements 2 and 5, right? There can be so many subarrays. You can have this as the subarray, you can have this, you can have this, you can have this. So there can be many subarrays, but remember the elements must be contiguous. You cannot have this as the subarray because it is not contiguous. There are two elements between them. So I hope you got the problem. So how we can approach this problem? The naive solution that first come to mind is that you start from 0th index. You get the sum at here. In this case, it is 5 as we're only having one element. And then you move forward and include the next element. If the sum is greater than the previous sum, you update the result. You see the previous sum was 5 and now it becomes 2, as 5 minus 3 is 2. So the previous sum was greater than this new sum, so we don't update the value here. And then you move forward to include the next element. So this time we are covering 3 elements. This time the sum is 0, still 5 is maximum, so we won't update the result. And this is how we cover all the elements till n. And this is the way we get all the subarrays starting from 0. And then we do the same for the next index and for all the other indices. This is how we get all the possible subarrays and their sum, and we find the one with maximum sum. But for this solution, we will be needing 3 for loops. One to fix the starting index, next 2 inner loops, one for deciding the coverage and another as a pointer till that coverage. So as you can see, this solution gonna take cubic time to complete. There can be many solutions to this problem. There can be a recursive solution. Recursive solution takes exponential time. There can also be a quadratic time solution to this problem. But the most optimal one, the linear time solution of this problem, is the one using dynamic programming. And it is given by Kadane's algorithm. So how Kadane's algorithm solves it in linear time? In Kadane's algorithm, we get the max sum ending at each index. See here, the max sum ending at index 0 is minus 2. Now the max sum ending at the next index can either be minus 2 plus 3, that is 1, or it can be 3. As 3 is greater than 1, so the max sum at index 1 is 3. Now see at minus 1, that is at index 2. Here the sum is either the max sum at the previous index, which is 3, plus the current value, or it can be the current value. So you can see the max one is 2. Now the max sum ending at index 2 is 2. So the idea of Kadane's algorithm is that the local maximum subarray sum is either the sum of previous max sum and current element, or it is the current element. Whatever is the maximum, it becomes the new local max. So we get all the local max at each index and then we find max out of them. And this is the solution. And this is much faster approach as it only takes O(n) time. So in this approach, you don't have to keep left and right pointers at indices to get the sum of elements between those indices, because at each index, we are holding on to the max till that place. We're not interested in knowing anything about the subarrays not having the max, so we're not keeping track of that. So see this. At index 2, either we can take minus 1 or we can sum it with the previous result. That makes it minus 1 plus 3, that is 2. So 2 is greater than minus 1. So the chain is going on. And then comes minus 3. If we sum it with the previous value, it becomes minus 1. Minus 1 is still greater than minus 3. So we include it, and then we have minus 2 at the index 4. So this time if we add minus 2 to previous result, which is minus 1, it becomes minus 3, which is smaller than minus 2. And we keep minus 2 this time. And this is the point where the chain breaks. So if you see here, this chain was going from index 1 to index 3. We were taking the previous sums and then we were adding the current values. Now at index 4, we were taking the value itself, and here a new subarray starts. However, we don't need to focus on the indices at which the subarray or the chain is starting or ending. We just need to know the maximum sum each index is ending up with. Alright, let's move ahead now. Here at index 4, we won't be including the previous result, as this value itself is larger than the previous max, right? And now here at index 5, we have 2. We will take the current, as the local max, the previous local max plus current is smaller than this current. And then at index 6, we include the element 5, or we include the current in the previous max sum. So max sum till index 6 now becomes 7. And then we have minus 3. We include it again in the previous local max to get the new local max, as this sum minus 3 plus 7, which is equals to 4, is greater than minus 3. And then at the last index, index 8, we add 5 to previous max sum to get this 9. So here we have all the local max. Now we get the max out of these local max, which is 9, and this is the final solution. Let's try this in IDE. So this is the array, and now we're going to create the method Maximum Subarray, and we're going to pass this array in this method. So let's pass the array, and it's going to return an integer. So let's take int max sum, and now let's create this method. Now inside this maxsum subarray method, we're gonna take a for loop, and this for loop is going to start from 1. So int I equals to 1 and I is less than arr.length and I plus plus. And the maxsum ending at 0th index will be the value of the element itself, right? So we're gonna initialize the global max and the local max initially with this element. So global max initially is the first element of the array. And similarly, the local max and local max arr0. Now we're going to calculate the local max for each I inside this for loop. So local max is either the sum of previous local max and the current value, local max plus arri, or it is simply arri, the current value, right? So we need to get the max among these two values, and that will be the new local max. So math.max. And now when we get the local max, each time we're gonna see if this local max is greater than the previous global max or not. If it is greater than the previous global max, we can update it as the new global max, and this is how we will get the final maximum global max. So here again we're going to use math.max to get the maximum of these two, local max and global max. So let's pass them, global max and local max, and this is the global max. And let's return this global max here. Now let's print this maxsum, sys out maxsum, and let's run this. So it gives 10, which is the sum of this subarray. So this is how you can implement this problem. You can implement the solution of this problem using Kadane's algorithm in a very few lines of code, which can execute in linear time.